Hello everyone, welcome once again to my channel. Now in this section we have a question on the method of moment estimators. So we are given the function f of s alpha beta being equal to 1 over gamma of alpha beta to the power alpha and x to the power alpha minus 1, then exponent minus x over beta. And then we are the question says that s is greater than 0, a is greater than 0, and then beta is also greater than 0. So in this case, this is a continuous case. But then you realize that we are given three different variables. Unlike the previous one that we used to solve, that we are only given one variable, and then what we have to do is to find the method of moment estimator for that particular variable. But in this case, we have two variables which are the alpha and then the beta. So let's look at how to solve it. So you realize that since we have two variables, we are going to get a system of equation where we have to solve, then find what alpha will be, and then find what beta is going to be. So from here, what we are going to do is we are given, so in the first case we have the expectancy e of x here being equal to the mean, right, which is equal to the square root of infinity, negative infinity x of x here. Yes, in this case. So in this case we have e of x here being equal to so since it is spread to the x, realize that the x is greater than 0. So if the s is greater than 0, then our upper limit is just going to be infinity, and then the lower limit will just be 0. And then we have x multiplied by f of x of alpha and then the beta. So we have this to be 1 divided by the gamma of alpha beta, that s to the power alpha minus beta, and then e to the power s over beta, the x in this case. So what we are going to do next is to bring any variable at which is no respect to the x. So we realize that we have 1 over gamma alpha beta outside, which are constant, and then we have this here, and then we are left with x multiplied by s to the power alpha minus that, and then e to the power, so e to the power negative alpha over beta here, the x in this case. So this is what we have in this case. Now what we are going to do next is that realize that solving this, we are going to use integration by parts, just multiplying this by that. We'll multiply this by that, we are just going to get s to the power alpha, and then we'll multiply it by this only. But then what I'm going to do is that I'm going to use the gamma function in doing this, the gamma distribution function in doing this, which is an easy way. So the gamma distribution function, the gamma of alpha here is given by the integral infinity 0 here, t to the power alpha minus 1 here, and then e to the power negative t dt in this case. That is from the gamma distribution. So from the gamma distribution function, right? So since we have this, what we are going to do next is to make this equal to that, because we are saying that the gamma of alpha here is equal to the whole of that. So how do we make this integral here? By comparing to this, how do we make it equal to that? We will look at that one. And then also from the properties of gamma, we have that the gamma of alpha plus 1 here is equal to alpha, and then the gamma of alpha. So these are the two properties. So let's call this one 1, and then let's call this one 2 here. Okay, so we are going to want to make this being equal to that. So in doing that, we realize that we have x here and then s to the power s minus alpha. So comparing this and that to the whole of the one here, we realize that when I multiply this by this, I'm left with s to the power alpha. So it looks similar to this, and therefore our t here is just the x here, and then e to the power minus t. So in this case, comparing this e here to what we have here, we realize that we have the e here, and then to the power negative,
and then basically t here will be equal to x over beta in this case. So if from here, right, by comparing them, t equal to s over beta in this case, now we want to write everything with respect to t. So all we can do here is to just make s the subject. So making s the subject, we have x being equal to beta t in this case. And what we'll do next is to differentiate x, because we want to write everything in terms of dt. So we have to find what the s is. So the x here, differentiating s with respect to t here is just going to be with beta. So therefore the x here will be equal to b d theta. So from here, so since we have b d theta, what we are going to do next is just substitute everything to it. So we have e to the power x, e of x here, 1 over the gamma of alpha, and then beta that, remember we are writing this one here, and then we have the infinity 0 here. So in this case we have this here to be x, and then we said that s is equal to beta t, so we have beta t here, then into bracket we have x here, which is still beta t to the power alpha minus 1 here, and then e to the power, we have minus x over b is just t, so it will be minus t here, and then we establish that the x here is equal to beta t, so it becomes multiplied by beta t in this case. Okay, so from here we have e of x here being equal to 1 over so we can just bring so we have beta and then beta t here, just substitute those ones out. So we have beta squared here. Another thing we can also do is that we have 1 over gamma alpha beta squared, and then this one here we have beta t and then beta t here as basis. Since the bases are the same, we just add the exponent, so we have this to be beta t here, and then we are left with alpha because we add plus 1 here, because this is also to the power 1, so we add alpha plus minus 1 plus 1, which is just going to give us alpha, and then we have e to the power minus t here, and then beta dt. So from here we can just bring this b outside here, and then remember we have beta alpha and then theta t to the power alpha, b to the power alpha, t to the power alpha. So since we are writing this with respect to the gamma function, which is t to the power alpha minus 1, just substitute b out. So we have b alpha, and then this b here divided by the gamma of alpha beta, remember this is beta alpha, and then we have the integral of infinity here. We are left with, we brought beta alpha out, so we are left with t to the power alpha and then e to the power minus t here, and then we have dt. So we have everything in terms of that. Now beta alpha will cancel beta alpha, and then we are left with beta divided by the gamma of alpha here, and then from here, remember we have infinity 0, t to the power alpha, e to the power that, and then dt. And then remember from the gamma function that we used again, we said that we want to make this one here look similar to that. So let me write the gamma function here again. So we have alpha here being equal to, this is still from the gamma distribution function, minus t here and then dt, and it said this is equal to the gamma of alpha, and then it also says that the gamma of alpha plus 1 here is equal to alpha and then the gamma of alpha, so 1 and then 2 here. Now if you look at it, which means that when we are able to write this look similar to that, then it's equal to that. Okay, so we realize that we have gamma here, we have 0 here, t to the power alpha minus 1, but here from what we have over here, we have just alpha, not minus 1, but then we have e to the power minus t and then the t. So realize that the only difference is that we have alpha here and then we have alpha minus 1. How do we make it to look a bit similar? So what I'm going to do is that from here I'm going to let another variable. So we let a variable, let's say b, be equal to so we can let b, or just let alpha, right, be equal to some beta minus 1, because I want to make it look similar to that. So I'm using another variable. I'm replacing alpha with beta minus 1 so that it looks like it is alpha minus 1, but then it's beta minus 1. So if alpha is equal to b minus 1, so which means that when I replace alpha here with b minus 1, it looks similar over here. So I'm just going to have so from here, if alpha equal to b minus 1, then which means that our making b the subject from here, we have b equal to alpha plus 1, and then when I have I add gamma distribution on both sides, so a gamma distribution and then a gamma distribution on both sides here. So gamma distribution of b is equal to the gamma distribution of alpha plus 1. So if that is the case, let's write the whole of this then again. So we have beta over alpha, and then in this case we have this to be that, and then t, remember alpha here we said is b minus 1, so b minus 1, and then e to the power minus t dt. Now let's compare this to the gamma distribution again. Now comparing the integral function here, so we have infinity here, we have 0 here, infinity 0, infinity 0, t to the power b minus 1, t to the power alpha minus 1, e to the power minus t dt, and then the same thing here. But then the only difference is with this and also that. Remember that if this place is alpha, which means that all of this one here will be equal to, if this is integral of we have infinity 0, t to the power alpha minus 1, e to the power minus t dt, which means that all of this is equal to the gamma of this alpha here. Therefore, if that is the case, then which means that the t minus b minus b minus 1 here, all of that will also be equal to, so all of this will also be equal to the gamma of b here. If this is equal to the gamma of alpha, which means that the emphasis is on the alpha here, because there is alpha minus 1 here, we have the gamma of alpha, and then because there is b minus 1 here, we have the gamma of beta. Now if that is the case, then which means that we have our e of x here being equal to, we have beta divided by the square root of alpha here, and then we have the whole of that being the gamma of b, right? If that is the gamma of b, then which means that we said that the gamma of b here, from what we did over here, we said the gamma of b is equal to the gamma of alpha plus 1, so we just replace that, is equal to the gamma of alpha plus 1 from here. So we said it from here that the gamma of b here, that is squaring, putting gamma on both sides, the gamma of b here is equal to the gamma of alpha plus 1. So if that is the case, then which means that we have the beta here, gamma of alpha here, and then from the computation, from the properties of gamma function, we said that the gamma of alpha plus 1 is equal to gamma, and then is equal to alpha multiplied by the gamma of alpha. So we have the whole of this to be alpha multiplied by the gamma of alpha. So in this case, gamma of alpha will get rid of gamma of alpha, and then from here we have our e of x here being equal to alpha multiplied by beta. Let's call this one equation 1, which is basically equal to the mu, right? Mu here equal to alpha, and then that, so that is basically equation 1. Now how do we get the second equation? So we got the first equation using the expectancy or the mean. Now the second equation can be we can get that out of getting the variance. We know that the variance here is just variance of x is equal to the summation of all of that. Then we have the mu squared. So in this case, this is written as the expectancy of s just by squaring the s, and then over here we have all of this here being equal to square, and that is equal to the variance. But then the idea is that we have to know what the variance is. We know what this is, which is expectancy. We know that it is alpha beta squared in this case. But then what is the expected value of when we square x? So when we square x, which means that it's going to be from s squared here, and then we have this to infinity to 0, and then the next one is just going to be the function, which is the f of s, and then our f of s is from the main piecewise function. We have the gamma of so from the main piecewise function we have this, that, and then alpha minus 1 e to the power minus x over the beta here, the x here in this case. So from here also we just going to use what we did for the other one also. So from here we just bring 1 over gamma, the whole of this out, and then we just have this to be that, and then having this, we just have this to be s to the power, we have s squared here, and then s to the power alpha minus 1. So when we add it to it, we realize that we are just going to get alpha plus 1 here, and then e to the power minus x over b dx over here. Now from here, we have established that from the first part that we let as we did for the first part, we let t here being equal to s over b, that is comparing it with the gamma function, the gamma distribution function. We said that we let t equal to s over b, that is using the first step that we used in finding the first equation, and then we said that we make b the subject, and then we have bt, and then the x will be equal to b of the t in this case. So if that is the case, replacing all of that, then e of that squared here will be equal to, we just have this to 1 over the gamma of s beta to the power alpha, and then we have the integral of infinity 0 here, and then we realize that if this is s to the power alpha plus 1, but s is just beta t to the power alpha plus 1, and then t to the power, we just have this to be, is x minus x over b. So in this case we have negative t replacing that here, sorry, e to the power negative that, then dt in this case. All right, so from here we have so what we are going to do is just bring, so from here we can just bring this one out, beta, but then remember it is b multiplied by b, because the x here is just b dt, which is, we can see over here is b dt. So from here we can just bring this one out, which is the beta here out. We bring beta out, and then we can also bring beta to the power alpha plus 1 outside here, which is from here, and then divided by the gamma of alpha beta to the power alpha, and then we have this here. So we are just left with t to the power alpha plus 1, because we brought the b to the power alpha plus 1 out here, and then e to the power minus t dt here. So from here we just have this to be beta, it's to the power 1 here, so we have beta to the power alpha plus 2 here, divided by the gamma of alpha beta, that, and then again when we compare this to the general distribution gamma distribution function, we said that the gamma of alpha here is equal to infinity 0 here, and then we have t to the power alpha minus 1, then e to the power, we have negative t here, and then the t here, and then we are saying that this is equal to the gamma of alpha. So when we compare the whole of that, we realize that we have alpha minus 1 here, and then we have, but over here we have gamma plus 1. So how do we make this being equal to that? So we can do that just by when we add 2 to the power here, that just by adding 2 to the power here, we realize that we can make it equal to that. So when we add 2 to the power here, which means that we have to add 2 to the gamma alpha here. So what we are doing is just add plus 2 here, so that we make this, the gamma function here, being equal to that. So we have gamma alpha plus 2 here being equal to this here 0, and then t to the power we have gamma minus alpha minus 1 plus 2, which is just going to give alpha plus 1 here, and then e to the power minus t dt in this case. So realize that this is just equal to, we have made it equal, so which means that basically the whole of this goes to the gamma of alpha plus 1. So we have e of s squared here being equal to beta to the power alpha plus 2, and then the gamma of alpha beta that multiplied by the whole of that, which now is the gamma of alpha plus 2 in this case, the gamma of alpha plus 2. So from here we have further simplifying this, then we can have this one to be alpha, so it can be, writing this in terms of indices, we can have beta to the power alpha multiplied by beta squared here, divided by the gamma of alpha, the beta of exponent alpha multiplied by alpha, and then this here. So this will get rid of that, and then from here we have the whole of that being equal to the beta over beta squared over the gamma of alpha, and then multiplied by the gamma of alpha plus 2 here. Now we said from another property is that if you have the gamma of alpha plus 1 here is equal to the alpha gamma alpha. So if that is the case, and then what we are doing is to just, so if we have gamma of alpha plus 2, which we have over here, then it's just going to be just you having your alpha plus 1 here, and then alpha plus 1 here also. So if this is equal to that, then which means that the es squared here is just going to be the beta. So this is just a property from the gamma. If you have the gamma of alpha plus 2 is equal to that, so we are just going to replace that, and then we have the gamma of alpha plus 2 here is just going to be replacing it with this alpha plus that, and then we can also have the alpha plus that. Okay, so another thing we can also do is that if you have the gamma of alpha plus 1, which is from here, so this can be equal to alpha, and then the gamma of alpha, so let's replace that, equal to the gamma of alpha here. So we just have alpha plus 1 here, and then the gamma of alpha plus 1 we are just replacing with alpha, the gamma of alpha. So this will get rid of that, and then all what we are left with in this case is just having a beta squared into brackets alpha squared plus alpha here, and then this is just going to be alpha squared beta squared plus alpha, and then beta squared, and then that is just going to be that. So from the variance we can write that is equal to our e of just squaring that, and then the minus of e of squaring that. So we can have the variance of x here, right, being equal to that. So from this equation we have this to be alpha beta squared plus alpha beta minus for this part we have this to be alpha and then beta from the first mean. So we square that, and then you realize that we have alpha squared beta squared. This will get rid of that, and then our variance of s is just going to be alpha and then beta squared. But then we can do that straight and get a variance. But then in this case, what we are trying to look for is the second part of the equation. We have the first part of the equation to be mu here being equal to alpha and then a beta. We call it equation 1. Now the second part of the equation will be, so the second part of the equation is from here, which is the finding the expectancy just by squaring s. So the second part of the equation here, so let's say u1 and then u2 will be equal to this squaring s. The first one was from the expectancy of s, which is equal to, the second one was just squaring the x here. So the second part of the equation now becomes this part, alpha squared beta squared plus alpha beta squared, and let's call this one equation 2. Now we have the two. Alright, so from here what we'll do is to let so from equation 1, we can use so we make a the subject from equation 1, which is u1 over b, and then let's call this one 3. So what we're going to do is to put equation 3 into 2. We're going to put 3 into 2, so u2 here will be equal to alpha squared, and then alpha squared will be u1 squared over beta squared here, multiplied by beta squared, then plus alpha. Remember alpha here is just u1 over beta, then multiplied by beta squared here. So this will get rid of that, and then this goes away and it gets rid of. So u2 here will be equal to u1 squared plus u1, and then with b. So remember we want to know what beta is. So from here we make beta the subject, so we have u2 minus u1 squared equal to u1 beta here, and therefore beta here is just going to be u2 minus u1 all squared divided by mu1, and that will be the value for beta. So in this case we can write the whole thing here, because our u1 here, remember, is just the mean, and then our u2 here, which is the second part of the mean, just 1 over the summation of all the the x here, all the s values here in this case. So which means that we just have this to be our u2 here is just that. So replacing that, we have 1 over n, this to be x, that here. Remember it is squared because it is the second part of the mean. So the second part of the mean, which is squared, and then so becomes squared minus, we have u1 here to be that the mean, so it also has squared, then we square this one also, divided by the mean here. So writing this in an appropriate manner, we just have this to be so n here, remember there is n here, and then we have I to the power 1, I to the power I equal to 1. So we have x I here minus s bar here all squared, because both of them are squared. Then we divide by, this n comes down, so we have n and then the bar of that. So that will be the value of b in this case. So if this is the value of b, remember we said alpha here is equal to, from equation 3, u1 over beta. So if that is the case, what is u1? u1 is just the mean here. So we have the mean here divided by beta. What is beta? Beta is the whole of that. So beta is the whole of that. So writing this in appropriate manner, then alpha will be equal to, we have the mean divided by beta is just the whole of that. So now it becomes this moves up because it comes up. So let's do it one after the other. Si minus s bar squared divided by n s bar. Remember it is s bar. So in this case, writing alpha here, then we have alpha here to be equal to, it is the mean divided by that, also divided by this. So this moves to the top there, then becomes the mean squared n, because it multiplies, and then with the n divided by the whole of that, which is n here, then I being equal to 1, s that minus that squared here, and that will give us a. So in this case, this will be our beta, and this will be the value for the alpha in this case. So this is a bit complicated, but then if you take your time, you'll be able to get it. So thank you very much for joining me in this section. I hope this session was helpful, and I'll see you in the next session, which will still be the last session on method of movement, but then it's just going to be something which is not complicated as today. It's just a simple one to this also. So I'll see you in the next section.